Okay, so this is the second problem from the second problem set of David Tong's lecture notes. So we're just asked to basically, given our fields and momentum field and these commutation relations, show that the raising and lowering operators obey the usual commutation relations. And again, there's not that much, it's just basically a matter of computing these things or writing them down. So for example, phi with phi, if I just write that out, this commutator, I'll get this, and this should be 0. And the easiest thing to do is, so the way he words the problem is to basically using this relation prove directly that, solve for what these commutators are basically, which in principle seems possible because you have three equations like this, and you have three unknowns, these three commutators you have to evaluate. So it does seem doable that way, but since they are like integral equations, I'm not exactly sure how you would do that. So the easiest thing to do is instead just show, assuming, now that we've written out this commutator, just assuming the creation and annihilation operators obey the usual commutation relations, to show that if they do, then this expression is true. So for the phi fields, in this case, this field is 0, or this commutator is 0, this commutator is 0, and then after you do all the integrals, these two terms will end up canceling, and you will get 0. And then basically it works out the same way for the momentum fields. These two are 0, and these two terms will end up canceling. And then when you do the phi with the momentum field, you just get, again, first and last terms are 0. This time, these two terms will add, and so you'll have a delta x minus y left over. So, so and that way you're more assuming, you're kind of doing the opposite of what he asked. You're assuming these commutation relations are true, are what they are, and then showing that if they are, then the fields and momentum field obey the correct commutation relations.